Alright, ladies and gentlemen, welcome to Similarity. Today we will be looking at ratios and using proportions to solve geometry problems. A lot of the stuff we're going to do today is going to be some review from some of the stuff you've done previously in algebra. So like I said, a lot of this stuff will seem like you've done some of it before. Alright, to start things off, go ahead and pause the video and either do a Google search for the three vocabulary words here. We've got ratios, proportion, and scale. Or go ahead and look in your textbook, page 356. We'll have all these definitions on there. You can also look in the back of your textbook if you want to find each word individually. So go ahead and pause it, take a minute, do the vocab, and then we'll go on with the lesson. All right, well, we've got that vocab figured out. Let's go ahead and do number one here. What we're going to do is we're going to practice writing ratios. Now we can write ratios in three different notations, and then we're going to simplify the ratios. So the first one we have is 76 centimeters to 8 centimeters. The three different ways we can write ratios are as follows. We can write ratios as a fraction. This would be comparing two things, A and B. So that we say A to B is how we classify this. We'd also write this as A colon B. Again, we still say A to B is the ratio. And the last would be A and then the word to B. So these would be the three different ways you could write a ratio. All right, so first let's go ahead and write 76 centimeters to 8 centimeters as a ratio. We'll do it as a fraction. This makes it easier to reduce. So 76 centimeters over 8 centimeters. Now the first thing that we'll notice is that we have centimeters on both the top and the bottom of this fraction. So what we're going to do is we're actually going to cancel these out, and we're going to get left with 76 over 8. Now 76 over 8 is a fraction. We want to reduce that. We never want to leave a fraction that is not reduced. So remember, to reduce, what we do is look for a common factor in both 76 and 8. In this case, it's going to be 4. 4 is going to go into 76 19 times. So 19 will go on top of the fraction. 4 goes into 8 2 times. So 19 to 2 would be the new ratio. Again, we want to write this three different ways. So we can write it as 19 to 2, 19 colon 2, and then lastly 19, the word 2, and then the number 2. Now it's important that the 19 stays on top of the fraction for the first one, and then the 19 is the first number in both the second and the third ratios. This shows us that that's the first number, and we're comparing the 19 to 2 in this case. For the second one, this is already in fraction form for us, so we'll go ahead and we'll cancel out the feet just like we did with the centimeters before. 4 over 24, we're going to look for a common factor. 4 goes into both 4 and 24. 4 goes into 4 one time. It goes into 24 6 times. So 1 to 6 is going to be the first ratio. This would be the second way that I could do it, and this would be the third way. The first property that we're going to review with proportions is what's called the cross product property. In a proportion, the product of the extremes equals the product of the means. So if I have proportion, which is two ratios equal to each other, A over B equals C over D, we're going to cross multiply such that A times D is going to equal B times C. So in this particular case right here, I'm going to take 2 and multiply that times 6. I'm going to take 3 and I'm going to multiply it times 4. Okay, 3 times 4 is going to be 12. 2 times 6 is also going to be 12. So this is verifying this is a true proportion. So we're going to go ahead and use that for this first problem here. So I have 3 over 4 equals x over 16. I'm going to use the cross product property to go ahead and solve for x. So we're going to start off by multiplying 3 times 16, which is going to be 48, and then 4 times x, which is going to be 4x. One-step equation, go ahead and divide by 4 on both sides, and x is going to be equal to 12. Now over here, we've got, for part B, I've got 3 over x plus 1 equals 2 over x. We're still going to cross multiply. I'm going to multiply 3 times x, which is just going to be 3x, and that's going to be equal to 2 times x plus 1. Now it's important to remember when I multiply 2 times x plus 1, it is 2 times the quantity x plus 1, which means I'm going to need to distribute this 2 to the x and to the 1. So 2 times x and then 2 times 1 is going to give me 2x plus 2. We want to get our variables on the same side, so I'll subtract 2x from both sides. 2x's will cancel. 3x minus 2x is going to be x, and that's going to be equal to 2. Now, if you want to check your answer proportion, we can just plug it in. 3 over 4, if you can kind of plug it in your calculator, 3 over 4 for the first one is going to give you 0.75 if you plugged it into your calculator. And if you did 12 divided by 16, it should give you the exact same thing. With part B, we should do 3 over x plus 1. X is 2, so 2 plus 1 is going to be 3. So 3 over 3 would be 1. And then 2 over 2 would also be 1. So that's just one way to verify that your proportion and what you got for x is true. Here are 3 additional properties of proportions. The first one is what we call the reciprocal property. The reciprocal property says that if I have 2 ratios that are equal, then the reciprocals are also equal. So remember, reciprocal means we take the fraction and we switch the numerator and denominator. So the a would come to the bottom, the b would come to the top. So b over a would be the reciprocal of a over b, and the reciprocal of c over d would be d over c. Our next property says that we can interchange the means of a proportion to form another true proportion. And remember, the means are going to be these two right here, which just means I can interchange these. That a over b equals c over d would be the same thing if I put the d in place of the a over b, and that would be equal to c over a. So I'm just switching the d and the a. And this proportion will have the exact same value as the original one. My last property takes my proportion, and if we add a number, we take the denominator and add to the top, it just holds true that the proportion will stay true. So a over b equals c over d. If I add the denominator b to the numerator a, that'll be the same thing as if I take c plus the numerator d and leave that over d. So as long as I add the numerator to both the top of both of my fractions, then this proportion will stay true. In example 4, we are given two proportions. Sorry, we're given a group of sides that are proportionate to each other. We have JL over LH equals JK over KG. So this is a proportionality statement. It tells me how these things are related to each other. And JL, LH, JK, and KG all represent line segments in the triangle that I have over here at the right. What we're going to do is take this statement of proportionality, and we're going to substitute the number values to find the missing side. So we'll start with JL. What we want to do is substitute JL for the value. Now if I look here, JL is this line segment on the right part of the triangle. Now we're not given what JL is, but we know that X is the distance from J all the way to H, and LH is 2. So whatever X is, if I subtract 2 from that, that'll be what JL is. So JL is going to be just that, X minus 2. We're going to put LH on the bottom of the fraction. LH, if you look at the triangle on the right, is going to be 2. That's the length of that segment right there. And then we're going to do JK. So if you look at the triangle, the length of JK is going to be 15 over KG, which is going to be 5. So all I've done is substitute the values in the diagram into my proportion. Once my proportion is set up, we're going to go ahead and cross multiply. So I do x minus 2 times 5. And again, we need to make sure it's 5 times the quantity x minus 2. So I'm going to need to distribute this. And that's going to be equal to 2 times 15, which would be 30. We'll distribute the 5 times x, and 5 times negative 2 gives me 5x minus 10, which is equal to 30. We'll add 10 to both sides. 5x will be equal to 40. Divide by 5, and x is going to be equal to 8. Now we're not done. If we go back and reread the problem, what we're looking for is the length of JH and the length of JL. Now what we just found here was X, which is also JH. So JH is going to be 8. The other thing I'd like to know is what JL is. And we already said JL is going to be X minus 2. So now we know X is 8. JL will be 6. So this is going to be your answer right here. All right, go ahead and try the You Try Now problems. Make sure we have that vocab done. And if you have any questions, write them down on the side, and we'll see you in class.